Welcome to the Select Star Podcast, your resource for innovative technology, developer topics, and more. Here's your host, Margo McCabe from the HarperDB team.
Hello, everyone, and thank you for tuning in to the Select Star Podcast hosted by HarperDB. Super excited today. We have a guest who pretty much needs no introduction. We are speaking with Kelsey Hightower today, and we are switching it up. We actually are going to have one of HarperDB's co-founders, Stephen Goldberg, doing the interview. So I will pass it over to them two.
Awesome. Thank you, Margo. And Kelsey, thank you so much for being here. We really appreciate it. And it's an honor to have you on the podcast.
Awesome. Happy to be here.
Yeah, we're super grateful. I thought I'd start off with kind of an easy question, maybe a hard question, and you've probably already gotten this a lot. You retired from Google this year. Kind of what's next for you? Where are you kind of taking things, and what are some reflections you have on kind of that journey?
Man, I think it's been about 2 months now into retirement. So I think one thing I'm realizing is you just end up working for yourself. I'm 42 years old, so my body gladly is not retired. And so you just start doing the things you should have been doing around the house, keeping up with finances, thinking about health, thinking about all those things. But also, I still do a lot of public speaking. So once I retire, you could imagine the number of keynote requests that came in. And so still been doing it on the road, sharing my thoughts about tech, my career, a little bit same as before, but people are very curious now, like, hey, what does Kelsey think unfiltered, right? It's always hard to remain neutral when you work at a company like Google for so long, right? You can't help but be biased towards the things that you and your teammates are working on. And so, getting a glance at that being unfiltered. And what's going forward? Well, just more of my kind of my own stuff, whether that's writing another book. I still advise startups, so I still like building things. Do I want to type all the code these days? Absolutely not. But there's over 10 startups that I advise, and they're all in the product building phase. Some names are recognizable, like Acuity, the team behind Argo CD. People are well aware of companies like Docker. And there's some newer companies in like the ML AI space that are also trying to get into this ML ops. So I'm not going to throw all of that experience away. So advising startups is still a thing that's on my radar.
That's awesome. That's very cool that you're still doing that. And yeah, I someday I'd like to be able to take care of the finances and health as well. I'm similar in age. I wouldn't say my body is still all together, but I'm working on it. The next question I have is, you have kind of a non-traditional background when it comes to tech. Me too. I don't have a CS degree and never imagined myself founding a database company. But how has that kind of shaped your view on the industry? What are your thoughts on kind of how the industry deals with folks who don't necessarily have that traditional background, with folks who, like, how are we doing mentoring folks, bringing more folks in, and just kind of generally thoughts there?
I think it's probably safe to say not having a CS degree is the traditional background. Because at this point, if we're just like being very honest, if you go to school and you get a CS degree, you probably don't need to know how to use GitHub. You probably don't need to know how to program in the most popular, not just languages, but frameworks that we actually use in practice. I don't think a lot of us are having people implement red black trees as part of the everyday job. So I think we have to separate the CS theory. I think a lot of people will claim, CS is not about computers, just like math is not about calculators. And so I think the industry has always wanted people with actual hands-on skills. And a lot of the things that I think people are building these days are just moving faster than CS curriculum can keep up with. So I think curriculum, in terms of what colleges provide when it comes to computer science, is very different than what we're doing in industry at this point. At this point, I would probably say a lot of people will be equally served in terms of a craftsman, getting involved in open source projects, going into your local meetups. Because when I think about people that go through the electrician route, they have a very concrete mentoring. Tools are well mature. People understand when to use the tools. They have regulation to back. You need to put a staple every 6 inches before a socket and things like that. I think in tech, what we can do better is just really make sure we understand that this is a craft.
Yeah.
There's no, you're born with it. Like you have some innate ability that no one person can learn. That's just not true when it comes to like JavaScript frameworks and building things that we use in production and doing all the integration work. I would probably argue there's more integration work than there is net new building of low level tooling. And so given that, I would say, you know, people joining tech, focus on skills, maybe don't spend so much time figuring out what's the perfect programming language. Like pick one that allows you to build the things you find interesting. More than likely, of the millions of companies hiring for people doing that kind of work, you'll find your spot. And I think if you're a seasoned person, you know, maybe 5+ years on the job, you have to understand another part of your growth trajectory is going to be your ability to get other people to be as good as you are. And if you can figure how to do that out, I think our industry will be pretty good, right? We need that pipeline, and that pipeline also requires on-the-job learning. So I always tell people, be careful that you don't go throughout your career with 10 years of 1 year experience because you failed to level up. And that typically happens when you're on a team that doesn't necessarily mentor people to the next level.
No, I love that answer, and I completely agree with you on that. When I actually started college as a CSS major, but I had learned to program when I was 13. And I remember they handed me a pencil and wanted me to write Java programs on pencil and paper, and I could barely write my name. And so that's all it took for me was that one experience, and I was out. But I totally agree with the path you're outlining, and I think mentorship and more hands-on and teaching people to be craftsmen and soft skills is a phenomenal way to go, and I'm hugely supportive of that. More on the technical side, and I apologize, some of these questions are going to be a little bit selfish for us, and so maybe we're getting some free consulting. But you know, one of the things, we're a distributed database company. We're focused on kind of, you know, putting HarperDB everywhere we can and lowering latency and that, but because we're a database, that comes with some challenges. And so one of the things that we look at a lot is, you know, where are we in the world today with monolithic architectures versus distributed architectures? We spent a long time looking at distributed, but as we look at performance, sometimes people start to turn the dial back towards maybe monolithic isn't the worst thing in the world. What are your thoughts there? Where do you see the trends going, and sort of how do you see edge computing being impacted by that?
I mean, I think these buzzwords just kind of throw us off from the fundamentals a little bit. For most people, we've always had edge computing, right? Like your desktop, the internet was the thing that kind of changed that a little bit. For some people, going back even further, you know, the mainframe, you had a dumb terminal on your desktop. So the industry will go back and forth as we get advances on either side of that equation. So I think there was a point where the cloud moved a bit faster. There were things you could do in the cloud. And remember, it takes a long time to get new technology on the edge, right? Apple does a phenomenal job every year of new cameras, new AI chips, new GPUs, but that's probably a 5-year adoption curve, even for loyal people in the Apple community who update their phone every year. So it takes a while. And then while we wait, we start doing things in the centralized world where we start enabling things like, you know, custom accelerators for model training, but then eventually that gets democratized and it's in every laptop. And so that pendulum will continue to go back and forth. I think the thing when it comes to microservices, that's a solution, I think, initially for a lot of people who just found themselves writing spaghetti code. It's easy to do. You have a team of 5 people, and they're all just trying to cram every feature bug fix into this singular code base. And you could try your best to do object-oriented programming, but you know how it goes. You reach into an implementation, you start modifying a method to do things it shouldn't do, a couple of if statements later, and now you have the spaghetti code. And eventually someone says, listen, I can't work in the same code base with you all. You make a mess, you know, I get it, the needs of production, bug fixes, but I'm trying to balance that with new functionality that may cause or require major refactors. I can't do that in the same code base. How about this? I'm going to take my logic out and I'm going to work over here. And honestly, that's not a big problem. If you think about just writing code modularly, like I am working on a user service, it's a module. It can be imported in a monolith, or it can be imported in a standalone binary. Fine. But I think people forget that big trade-off. The moment you split logic across the network, now you have to serialize the data, you have to secure the data, and then you have to make networking round trips. So by the laws of physics, it's going to have worse performance, period. I don't even know how people try to work that part out. You still have computers and logic that you have to deal with. So I think a lot of people are realizing having 5,000 microservices as a goal is insane. Having logical programming modules has always made sense. So I think what people are realizing is that, look, we should make modular code no matter what. And when it makes sense, maybe you bring the authorization module in process so you don't have to bounce around the wire to do authorization if your performance needs requires that. So to me, start with the monolith, but write modular code. So if I open up your IDE, what I should see is import service A, B, C, D. If you're using HTTP, you can route traffic to each of those services, and you can treat them like mini embedded microservices, right? They can all have their own database. They can all have their own config. Nothing stops you from doing that. But if the time ever came, let's say you want to integrate with the service that the SDK is only in Java, but everything you've written is in Python. You know what? As a team, we may get together and say, team, let's just use the JVM for this situation. And then that requires it to be on a standalone binary. And we get it. And we may deploy it on its own server. Or, in the days of Kubernetes, we may put that Java app as a sidecar right there on the same machine so we can cut down on some of the latency and just go over localhost. So that's just my thoughts around these architectural decisions. There's no best practice. There's just practice.
I hear where you're coming from that, and I like that a lot. I think the next, and I kind of maybe misused a word there because you're right, the buzzwords do get a little bit confusing. And I think one of the other things I'm curious to get your thoughts on is, as we look at things like edge computing centers, or as there's sort of this land grab by the cloud service providers to say, I'm coming on in more and more locations, and I'm putting more and more edge compute out there. And containerization is making it possible to deploy your apps in smaller ways and smaller things. Don't you think that's going to reach kind of a breaking point at some point? There's only so many places you can put a data center on the planet. I'm going to need to put more and more hardware there. I guess my question is, what are your thoughts on what the sort of cloud service providers, the network service providers are kind of going to invest in next? And kind of where do we go from there is kind of my question.
All right, so there's an opportunity. Right now, my laptop that I'm talking to you on right now is probably bigger than some people's data centers 15 years ago. My laptop is probably bigger than people's, at least your half rack that you had. So we know this compute footprints get bigger. And so what do you do with it? So if you're a cloud provider, forget cloud provider for a second. If you're a provider that has the capital to go chase these opportunities, you're going to chase them. So if a self-driving car network needs 5G low wave so they can go fast, then Ericsson or Google or Microsoft or Amazon is going to deploy micro towers so that cars can talk to each other. That will be a thing because the opportunity will be there. We have the tech, and now we need the investment. And so when we say cloud provider, I think we're also saying companies big enough to make $100 billion investments and get returns over a decade. Mom and pops are not doing that. So I think cloud provider has become the new ISP, right? If 20 years ago, we would be saying this about AT&T and Sprint, right? Like they would go out and build all this infrastructure, and then now we get mobile phones. So I think cloud providers are the customers that choose to partner with a cloud provider. They go and say, listen, we're Netflix. We want to deliver video anywhere in the world at 4K. We can't do that from one region in the world. We need you to go flood the earth with making that easy. And so in partnership with Equinix, ISPs, the cloud providers figure out how to move that footprint closer to all these things and put a UI on top. So the next Netflix that we end up with won't have to go figure out infrastructure. It will just be a thing. That won't stop. I think where you're going to end up with is Walmart will do it. I think right now we think of Google and the bookseller, Amazon. What happens when Walmart gets into the game? What happens when Burger King with all of their locations gets into the game, right? Because they have footprint, they have the physical assets. What's stopping them from being one of these points of presence where you can stream video and things like that? So I just think that's just a natural reaction to how humans work. And then the last thing I would say here is there's also the sovereignty problem, right? If you're a country that depends on another country for all your tech services, and tech is becoming a bigger part of your citizens' daily lives, you're probably going to be asking providers, and it's already happening, hey, you want a data center in Germany? It will be run 51% by German citizens. It will be on this soil, and the data will never leave. And so that's just natural, going to push more and more stuff to the edges. And the same will happen for cities and counties. And if you look at most people's homes, I have some Ubiquity gear, have my own hard drives in it for closed circuit cameras. Like, people have many data centers in their house.
It's the worldwide Beowulf cluster, sort of, is what you end up with. I like that perspective. That is very interesting. I think along those lines, when you're kind of building a product for a scenario like that, or maybe it's something, along the lines of the AI ML stuff you're talking about that doesn't need to, maybe it needs to be distributed, maybe it doesn't. One of the things we always struggle with is there's all these amazing tools out there that you've spent a lot of your career, pioneering, and like Kubernetes, but other things as well. And when do you make the decision when it comes to automating these pieces? Do I put this in my product, or do I use something that's out there? And quite honestly, this is something we struggle with on a daily basis, because we go to look at a platform, we're like, oh, that's awesome. We're not the smart guys. There's a lot of people like Kelsey out there who have already figured this out. And then we go to use it. We're like, oh, but it's missing that thing. And we end up building it all ourselves. How does someone who's much smarter than us, such as yourself, make that decision? And where do you draw the line?
You know what? I think you're thinking about this correctly. And I think every platform team on earth has this problem. A vendor says product does all these amazing things. They buy said product, they put it in production, and then there's this gap. And that gap is typically the stuff you have to build, you layer on, it's in-house. And then 5 years later, you go to a conference and they're like, hey, this is the new baseline. And you're like looking at the team like, man, we built all of that. Now, do we get rid of all of that? And the answer is no, until that becomes mature. And now you kind of have this gray area of waiting for the other thing to be mature and maintaining the thing you already have. But I do think it's important to pay attention when the new thing shows up, and then make that decision as a team. You know what? Let's just contribute to that open source thing and put on our roadmap that now we're going to target towards that. And there are some things we're going to do with our current homegrown situation that sets us up to adopt that thing when it comes, right? And that could just be an API change, API compatibility. It could be, let's just run them side by side, but only using 1% of the features from the new thing, but keeping the rest for ourselves. So if I was a company like yours, I think the number one thing is, I had the same problem when I was at CoreOS, right? etcd is this distributed database, but the truth is it runs really great as a single node, right? And etcd needs to be smart by itself. So when running on basic infrastructure, you can put it into an auto-scaling group of one, use a detached device so that if the VM dies, the storage will be reattached, and etcd will do a good job all by itself without a distributed cluster. It scales down. Single binary, put it on a VM, good documentation. I think that's easy in my mind, because anyone that has their own automation tools, they know what to do with a binary. They know where to put it. They know how to deploy it. Now, how do you scale up? I think when etcd had built-in cluster membership, that's something Kubernetes doesn't really have. Kubernetes can keep 3 things running, but it has no idea which one is node 0, node 1, node 2. It has no idea what the situation is in terms of RAF replication. That's up to the database to be smart. So I think the way you complement all of these scenarios, you say, hey, look, if you want to run my database manually across 3 nodes, here's the flags you set when you don't have an orchestrator. If you do have an orchestrator, then we need to do less work on our side, and here's the flags you need for that scenario. But I would always have a situation where the manual experience is pretty good. It doesn't need to be easy. It needs to be good. these 12 flags on 3 VMs is going to get you what you need. Now, anyone that's really good at Kubernetes can take that documentation for manual mode and probably port it to the Kubernetes model. And then I think there's another discussion here is when do you build like the operator, right? There's been a lot of noise in the industry of like, oh man, we should have a Kubernetes operator for our database. Yeah. And for those that are new to operators, if you ever go to the cloud and you click on RDS, right? RDS is like Amazon's control plane for Postgres or MySQL. And a lot of people think they're just getting this open source Postgres instance on a VM somewhere. Maybe that's part of it, but there's a whole control plane that's like, if it fails, make sure that it comes back up. Hourly snapshots to make sure your data is preserved. All kind of things to make sure that this thing stays up. All of that code, my guess, rivals the actual implementation of the database itself. And so that control plane complements the data plane. Kubernetes has part of the data plane, meaning we will take the container and put it on a VM. We will attach storage to the VM. That's like, I don't know, 30% of the data plane puzzle. But then your database is the 70% part, like you actually receive traffic and write bits to disk and possibly replicate and keep state under control, parse queries. Kubernetes knows nothing about that. That's on you. The other part of this is that, how do you do upgrades? Ooh, again, I go back to manual mode should be very clear. Here's how you do upgrades manually. And I think when you work that out and you document it, you have a clear state machine. Take down node 1. Node 2 and 3 will continue to perform because of cap theorem. You upgrade node 1, it's going to reshuffle the bits on disk if necessary, but they're going to be backwards compatible with the older version. We support 2 versions, right? Back and forward. And so if you do that manually and it's nice experience manually, then I can debug and troubleshoot when automation tools fail, right? I have a break glass approach. And so to me, I would make sure, hey team, before we do any controllers or any operators, make sure the manual mode is clean. We'll use the manual mode to drive the operator. And now the operator is simply just going through that state machine. And if we're being honest with ourselves, computation is hard. In number of flags, in number of scenarios, in number of supported versions means that you're going to end up with like hundreds of thousands of operator code just going through the various transitions and states that the thing could be in. So I don't know, maybe you target day 1. We help it easy to install, get a decent configuration, but then after that, you got to go to manual mode for tuning. Maybe we'll handle upgrades if you're in a certain state. Our operator can go from state A to state B, but if you're trying to go from state A to state C, our operator's like, yo, you got to go to manual. I can't handle that permutation because it's too dangerous. This is your data we're talking about. That is what I think needs to be articulated when you're dealing with things like data. And so this is why I've always kind of discouraged people. Do not think Kubernetes is like this magical Band-Aid you rub on a database and it turns it into RDS. That's not what's happening. But if you're a database provider, you can do things that makes running something like your database in Kubernetes much easier, being explicit about where your data lives. If there's a wall file, write a head log, make sure that it's in a specific place. Can I decouple it from the data volume and have it on the disk and data on a detached one and then recover in another way? Health checks, please. Can you just put health checks in the app, make that easy? Little things like that give an operator a chance to pick not just Kubernetes, but whatever comes later.
You just made me feel a lot better, I guess I'll say. So we do provide, we've not built an operator. We do provide some stuff. We have a Docker container. We provide like some things for doing it yourself. On our service layer, we actually don't use Kubernetes. We'd like to at some point, but we've been so afraid about some of the things that you've said that we've kind of spent the last several years just focusing on kind of manual mode and getting it better. Because quite frankly, we're just scared, and people's data is critical to them. You don't want to lose someone's data, and so we'd rather be putting things together with band-aids and chicken wire and stressing ourselves out than losing someone's data. So thank you. That is the relief, and I'm going to share that with our DevOps team for sure. One of the questions that came from our DevOps team, and I think you answered a lot of this, so I apologize if it's redundant, is and you kind of did, but it's like, what are your opinions on running stateful applications or the data consistency across its replicas, such as database. The auto scaling you touched on, redundancy you touched on, and it seems like the community in general, as we look for feedback, is kind of split on whether or not we should even be trying it. I guess you kind of touched on a lot of that, but would you say that ultimately, based on the advice you just gave us, there are areas where it helps, but we need to be careful, I guess, is the kind of the question.
Yeah, I mean, I think a lot of databases have been plagued by trying to adhere strictly to POSIX semantics, right? There is a local disk mounted to me that is fast. And so I can get away with things like, I don't know, writes, and then assuming that everything is safe, right? And databases that don't do that, they use write-ahead logs, and they try to do all this stuff for if there's a power failure between a transaction being committed. So I think we kind of understand that for a single node. Once we get into this replication situation, I think the confusion is, why are we replicating this data? For a lot of people, it's a good way to get around unstable infrastructure. So if I have nodes that can fail at any given moment, me replicating using something like RAF means that I just have multiple copies, and I can guarantee within some time boundary that your data is going to at least be across 3 different nodes. But if 3 nodes are on the same rack, then, does that even mean very much? So I think some of these workarounds to the limitations of current implementations of how most people run their systems, they are helpful. But I also see things like a company I advise called Red Panda, for example. They're a Kafka clone written in C++. They've done something really cool, which is like we got with you have cache on the CPU is hyper fast. Then you have RAM, which is fast. Then you have SSDs, which is pretty fast. And then you have spinning Rust. What they've done is added object store to the equation. So now their database will constantly page out, if you will, to S3 buckets. So if you have a petabyte of data, you know that every hour, every 10 minutes, every whatever your network can handle, this thing is constantly dropping to object store, caching what it needs on the local disk, putting things in memory. So now your tiered storage has expanded to object store. And the way they do it now is that if you bring up a read replica, it can just pull from object store, which is getting almost 11 nines from most cloud providers, and be able to serve a bulk of that data. That's a game changer for people building these systems. So if your storage architecture looks like that, then running it on something like Kubernetes becomes dramatically easier, right? I can lose a whole cluster, spin up another cluster, point at an S3 bucket, and then this thing is back off to the races, performing transactions again. So I think the database, it's on them to figure out how to store data safely. But doing with pure POSIX, that's where it all gets hard. Like managing like local disk with Kubernetes and then trying to make up the difference with Raft, that is not guaranteed to work always for everyone. So that's where I think the operational concerns are hard. But as a database provider, you can say, you know what? We can do constant pages to S3. Then backups become much easier. What are we doing backups for? Stop the world on the database and then trying to take a snapshot super carefully when I know my semantics and I can constantly stream things to S3 to complement everything. So once you operationalize a database at that level, look, of course you're running on Kubernetes, but that is not the majority of the data. Majority of the databases right now is turn off 2 nodes and you're done.
Yeah, our model's interesting in that, this isn't about us, but just because I think you might find it interesting. We use a mesh model where everything essentially is replicated to every node in the world as fast as the network will allow it. And so my thought has always been, I don't really care if we lose a handful of nodes. It's always behind a load balancer. Typically, we're dealing with full replicas of the database. You might experience some lower latency, but once that node comes back on, we do have an entire catch-up routine. It can get back to state eventually, put it back in the load balancer. It's kind of good to go. And I battle this with the DevOps guys constantly because they can't, like, that scares the hell out of them. But I kind of feel like we should trust in that, especially considering the use cases we deal with are, it's gaming data. It's that type of data where 10 minutes from now, it actually doesn't even matter that much. And so that's kind of the areas we focus on.
But one thing that you said that's really cool is your database is hyper specific and tuned for a set of use cases. I think the way people think about Postgres and MySQL, they try to use it as a substitute for specialized databases. And I think the thing you just said that resonates so well is that, look, we're making a storage trade-off. We're going to spin that data 3x. I think things like CockroachDB, they may decide like, hey, we don't want to store the same data multiple times because then a petabyte means 3 petabytes in the 3-node cluster. Whereas I think it could be 2 if you were to, shard your data in a certain way on the back end. You're saying, hey, that's too complicated, or it's not reliable for the use cases we want to deal with. We just replicate the data everywhere. And for gaming situations, all the clients and servers probably want the same data. Why not send it to all the nodes? And then you can deal with 2 out of 3 going down and still having common state across the last standing node. But I think that's the stuff that people have to think about and say, given that architecture, it may lend itself to more favorable conditions in a hostile environment.
Yeah, exactly. And like, I think Cockroach is an incredible product. People look at Cockroach and HarperDB a lot at the same time. And, we'll often say you should use Cockroach for this use case because they've made certain decisions that make a lot more sense, like a fintech use case with Cockroach is globally acidic. And I know why they do the things they do. I think one of the things that's interesting about solving these problems is you have to remember what is the business problem and the functional problem I'm trying to solve. Now I can go back to the technical, not the other way around. I have not really consistently written lines of code in 2 or 3 years. So I kind of have gotten to the point where my opinion doesn't matter as much, but I still try and get people to kind of pan out that way. But I really appreciate your insight on that. I know we're kind of running out of time. And so the last question which we hadn't planned to ask you, but I'd love to ask you is, what advice would you give yourself 20 years ago? If you could talk to that person, what would you say to yourself, and kind of what advice would you give you?
I mean, I think for me, if I were to rewind the clock, given how appreciative of where I am today, if I went back 20 years, I would say all the struggles, that's where the stories come from. All the things that don't work, that's where the stories come from. All the challenges, all the imperfections, that's the only thing that makes this stuff interesting. If you went through a perfect life, you don't really have much interesting to say. It's like, yeah, everything was all set for me. I never had an outage in production. I'd never written a bug before. I never fixed a bug before. That you can't get a lot of experience from that. So I think going back 20 years, I'm like, it's going to be an amazing ride. Pay attention to the details, all the human interactions about whether we should use Jenkins or this other thing, all of those human interactions around how decisions get made, the outcomes of those decisions, whether they were good or bad, how could you have improved? But I think a lot of people are just kind of going from junior to senior way too fast. Right. I think, of course, look, go get your money. I get it. But there's a lot to learn. There's lots of nuance. So when people say I'm a senior engineer, I would like that to be wrapped up in some experience, some fails, some successes, some learnings. And I think if you let it bake, it'll come out the oven just right. So I would imagine 20 years ago, I'd be like, yo, dude, it's going to be dope in 20 years from now. But don't rush. None of these decisions at a low level matter, whether you do Go or Python. It doesn't matter as much as you actually building, executing, and getting some real experience. And you'll be able to take that with you to any walk of life.
I love that. I love that. Thank you so much for being here. And it was wonderful to get to meet you. It's kind of, for me, this was an experience of my career that I'll get to remember for a long time. So I'm really grateful for your time.
Awesome. And tell the team, thanks for having me on the podcast. And look, I mean, this is an exciting time to be in infrastructure. I remember when it was boring. The best we're going to get is a new version of Bash. And right now, everybody has so much opportunity right now. So hopefully they enjoy the ride with you.
Thank you.
Thanks for listening to Select Star, your resource for innovative technology and developer topics. You can find our episodes in all the usual places: Spotify, Apple, Google, RSS, and YouTube. Don't forget to rate, comment, subscribe, and share. You can learn more about HarperDB at harperdb.io.